Hello everyone. Now we are going to see the sequence problem. So your question is long sequence of a pulse entered a 2 input and 2 output synchronous sequential circuit which is required to produce on output z is equal to 1 whenever the sequence 1 1 1 occurs. Overlapping sequence are accepted. Input is 0 1 0 1 1 1 1 1. The required output is 0 0 0 0 0 0 1 1. We are going to design the circuit. Whenever you are getting a 4 consecutive ones, your output will be 1. So initially we started with the state A. Assume that this is input is 0 and your output is also 0. We are designing the Millet model. So what I said, you should have the 4 consecutive ones, then only your output is 1. For the remaining all the inputs, your output is going to be 0. So your initial condition is 0. So now you're going to detect the first sequence. This is my first input and my output is 0. That state I'm considering as a B state. This is my first input and I'm going to detect my second input. So whenever you're detecting the second input, it is moving to the other state as a C. Next, this input is also 1 and your output is 0. And next, now we are in C. Now I'm going to detect my third input. So whenever you're detecting the third input, it is moving to the D state. Next, I'm going to detect my fourth input. So already you know that your D is nothing but 1. So again, I'm detecting my fourth input. Whenever you're detecting the fourth input, it is retained in the same state. Now your input is 1 and your output is also 1. What is the sequence? If you are getting 4 consecutive ones, your output is 1. Now initially if it is 1, you are detecting 1, it is moving to B. When you are detecting 2 ones, it is moving to C. When you are detecting the third one, it is moving to the D. When you are detecting the fourth one, it is retaining in the same state. So whenever you are detecting 4 consecutive ones, your output is 1. For the remaining all, your output is 0. So that's why you are writing 1 by 1. Your input is 1. You detected the fourth input as 1 and your output is 1. Here, this is my third input. Your input is 1 and your output is 0. So we have completed the sequence. But still, we didn't complete the problem. So whenever you are detecting the second one, it is moving to the C state. Suppose if your input is 1, that means your first sequence is 1 and your next value is 0. So what will happen? Instead of 1, you are receiving your input as 0. That means it is moving to the initial condition. Your input is 0 and your output is also 0. Next, you are detecting 1 1 1. It is moving to the D state. Suppose if you are detecting 1 1 0, what will happen? Your sequence is wrong again. So again, it is moving to the initial condition. So your input is 0, your output is also 0. Next, you are detecting 4 1. If you are detecting the 4 ones, it is retaining in the same state. Suppose if you are detecting 1 1 0, where it will move? Again, it is moving to the initial condition. What is the initial condition? This is the initial condition. So like that, you have to draw the state diagram for the given sequence of input. So what is the next step? You're going to write the transition table. How are you going to write the transition table? So you are going to start with present state, next state, and output. So present state and next state. Next state means when x is equal to 0, x is equal to 1. Similarly, for the output, x is equal to 0, x is equal to 1. So start with present state. What is the present state? So initially I've started with A. A is your first state, then B is my second state, C is third state, and D is my fourth state. So when your first state, that means present state A, if your input is 0, it is moving, it is in the same state, right? State is A and your output is 0. Next, if your input is 1, it is moving to B state and your output is 0. Next, now we are talking about the B state. So when your input is 0, it is moving to A state. If it is 1, it is moving to C state. Your output is 0, 0. Next, now we are talking about your C state. If it is 0, it is moving to A state and your output is 0. It is moving to D state and your output is 0. So when your input is 0, for the D state, it is moving to A, and if it is 1, it is retaining in the same state and your output is 0, for your output is 1. So this is nothing but your transition table, right? Now just assume that A is equal to 0, 0, B equal to 0, 1, C equal to 1, 0, and D equal to 1, 1. So based on this transition table, we are going to write the QA and QB. So already we assume that A is equal to 0, 0, B is equal to 0, 1, C is equal to 1, 0, and D is equal to 1, 1. So now I'm going to give the value for A. If your present state is A, I'm going to give the value as 0, 0. And if your input is 0. Next again, my value is 0, 0, my input is 1. Next B, 0, 1, input is 0. Next B, 0, 1, input is 1. Next 1, 0, input is 0. Next 1, 0, input is 1. Next 1, 1, input is 0. Next 1, 1, and input is 1. So based on this, we are going to write the next state. Already we know that A means if your input is 0 and your present state is A and your next state is A. So A means already we know that value is 0, 0. So you are going to write the state as 0, 0, next state. Then if your present state is A, when your input is 1 and it is moving to B state and B value is 0, 1. Next 0, 1. Next state is A when your input is 0. So it is moving to 0, 0 state. And again B, if your input is 1, it is moving to C state, 1, 0 state. And next 1, 0 and it is moving to A state. Next it is moving to D state. Next it is moving to A state. Next it is in same state. So based on the previous transition table, I have written this transition table. Already you know the output also. Your output is 0, 0, 0, 0, 0, 0, 0 and 1, right? So based on the previous transition table, I have written this one. Now I'm going to use the D flip-flop. So just I'm writing DA, DB. I'm going to use a D flip-flop and I'm going to design the circuit. Which circuit? Synchronous sequential circuit for the sequence detector problem. So if QA is 0 and QA is plus 0. So what is the answer for DA? Answer is 0. So we are going to use the excitation table. Already you know the excitation table for the D flip-flop. This is QN, QN plus 1 and D. 0, 0, then 0, 1 and 1, 0 and 1 1. If your D is 0, your next state is 0. If D is 1, next state is 1. If D is 0, next state is 0. If D is 1, your next state is 1. So this is nothing but your excitation table for D flip-flop. So based on this, I'm going to write the value for the D flip-flop, right? Next, so for the first one, 0 0, your answer is 0, right? So based on this, we are going to write the value for D. So based on the QA and QA plus, I have written the answer for DA and DB, and your output is Y. And now we are going to do the KMF for DA, DB, and we are going to draw the diagram. So by using the KMF, we got the answer for DA and DB. Now we are going to draw the diagram for synchronous sequential circuit using D flip-flop, right? So we know that DA and DB. This is synchronous sequential circuit. So your clock pulse, it's going to be common for both the flip-flop. This is clock. This is A flip-flop and this is B flip-flop. DA, QA, QA bar. This is DB, QB, QB bar. So what is the answer for DA? You need two AND gate, one OR gate and connected to DA. So the input is QA and X. This is QA. This is X. And the other one is X and QB. DB. And this is X. QA and QB bar. So from here I'm going to connect QA. From here I'm going to connect with the QB bar. So this is the diagram for your synchronous sequential circuit for the sequence detector. Thank you.